Okay, welcome to Quadratic Equations Part 2. Now what we're going to do is we're going to try and graph another example, and we're using standard form because it's very useful. So just as a reminder, whoops, turn my pen on here. Okay, as a reminder, we're talking about, didn't turn on. Okay, we're talking about equations that look like this, or functions rather. They're in this form, a very useful form when it comes to producing a graph. So this is what we're after. Okay? And these numbers can identify exactly where the vertex is, and then the number A over here kind of tells us whether the parabola opens up or opens down and how narrow or wide it is. So I'm going to start off with an example here, and maybe what I'm going to do is just pull this down, pull up the grid, and give myself enough room for this example. So let's pull out the grid, and I think I'm just going to leave it right where it is and start writing over here. So here's what we want to graph. We want to graph y equals 2, and then in brackets, x plus 1 squared and minus 4. So that's what we're trying to get a picture of. So step number one with all this graphing is to figure out just where is the vertex. Well, just like in the absolute value functions, you really want to just identify where does the stuff in the brackets here turn to 0. Well, that's when x is negative 1. So I know my vertex is when x is negative 1. And if I plug that in, just like in a table of values, negative 1 plus 1 gets wiped out, becomes 0. So I'm left really with just minus 4. So there's my vertex. So let's go ahead in the grid here, and we're going to graph that. Negative 1 and negative 4. Okay, so there's where the vertex of the graph is. Now, all I really need is maybe one or two other good points, and I'm just going to go ahead and list them here. I think a really good point, because it's the y-intercept and it's easy calculations, is when x is 0. If you plug 0 in here for x, you're going to have, let's write it underneath, 2 times 0 plus 1 squared minus 4. So we're just going to work that out. So we're going to get a 1 here, and the 1 gets squared. So just 1 minus 4. So I think we're looking at negative 2. Now the bonus of this is when I look at where the vertex is, I got 0, negative 2. Well, I know it's symmetrical, so at the same time, I know I got this point over here. So that gives me a pretty good idea of the shape of the graph. Now, there is one other set of points which is really going to give you a much more accurate graph. I could keep trying table of values, but we really want to look at just where are the x-intercepts. And that's going to give me a very accurate graph when I extend these lines around and up through the x-axis. So this really is worth the trouble of calculating. And we know they occur when y is 0. So a little bit of algebra to do here. What we've got is 2 times the x plus 1 all squared minus 4. And I'm going to try to solve this thing for x. I'm going to show you a little bit of tricks that we use here. So I can give myself a little bit of room. Okay, so what are we going to do here? Well, I'm going to start by adding 4 to the other side. So we got 4 equals 2 times the x plus 1 all squared. Then I'm going to divide the 2. Notice I'm not expanding out the brackets, because that would make things more difficult in the long run. Okay. Now at this stage, whoops, I got smudged. Anyway, at this stage, I have something squared equals 2. So to get rid of the squaring, I'm going to square root both sides. So I got root 2, and by the way, this becomes plus or minus. And over on this side, well, the square root of something squared just gets rid of the squaring. My last step is to subtract the 1 over. So this mess here, it doesn't look very pretty, but it's very accurate, and it tells us exactly what the x-intercepts are. So let me just write over here how you would calculate them. So these are your x-intercepts. You would go negative 1 plus root 2. And for graphing purposes, I'm going to work that out. So negative 1 plus root 2, I got 0.41. And then I would have negative 1 minus root 2. And again, for graphing purposes, that turns out to be negative 2.41. Now these are actually the points 0.41 comma 0. So I'm going to just pull up the grid and I'm going to plot these 2 points. So very accurate. Now I know I'm crossing the x-axis at 0.41, so right about there, and at negative 2.41, so right about there. Now that really shows you where that parabola is going. So I'm going to try and do a relatively accurate job here. Okay, something like that. And there it is. So let's extend this arm a little bit. And voila, we have a very accurate graph. We found the x-intercepts. We can see from the graph the y-intercept is negative 2. And we know that the vertex is at negative 1, negative 4. So lots of pretty good accurate stuff and not too bad. This is probably the messiest bit of algebra over here, but it's pretty logical sort of stuff. Okay, so I think that's where we're going to stop. Keep the lessons nice and short, and we'll come back with a part 3.